the review day for expanding and condensing logarithms. The test will be shared with you at the end of this period. Good luck. So remember, we want to expand this completely. So it's all together. We're going to break it apart. The log of t to the second power n to the seventh power. So I like to analyze what is going on. Well, I've got multiplication inside of my logarithm. So if I have multiplication inside of the logarithm, I can break this up by making this an addition problem on the outside. So if I have factor times factor, I can make this log of t squared plus log of n to the seventh. And the reason why I can do this is because of the product sum rule. I like to cite my source. So now I ask myself, is this completely expanded? Well, my next best trick, I notice that I have exponents inside of this logarithm. So the t squared makes the exponent fly to the front by using the power factor rule. So now I've got 2 log of t plus 7 log of n, and the reason why that works is because of the power factor rule. The power becomes a factor, and looks like this is pretty expanded. That looks as good as it's going to get. Okay, number 2. The natural log of p to the 11th over h to the 14th. Sorry about the sloppy, I'm using a marker to make it vibrant and noticeable. So what's the big picture of this problem? Well, I've got a numerator over a denominator. So if I've got a fraction or a quotient inside of my logarithm, I can expand it with numerator minus denominator. So this becomes the natural log of the numerator, p to the 11th, minus the natural log of the denominator, which is h to the 14th power. And the reason I can do that is because of the quotient difference rule. So by quotient difference, this is why I expand it like this. But is this completely expanded? You've got an exponent in your logarithm. You've got another exponent in your logarithm. So the exponents can fly to the front using the power factor rule. So this becomes 11 natural log of p minus 14 natural log of h. And the reason why I can do that is because of, yet again, the power factor rule. I'm going to use a different pen since this one doesn't seem to click correctly. Power factor rule. Much better. Okay. Now we're in the intermediate stage. Log of a to the 9th, c to the 12th over d to the 8th. What is the big picture? So I've got a numerator over a denominator, but I've got a multiplication problem in my numerator. So why don't I make this easy? So my theory is, hey, tops are positive, bottoms are negative. So if I expand this out, I'm going to say log of a to the 9th, since it's on top, it can be a positive. C to the 12th, okay, it's on the numerator, so it can be expanded with the product sum rule, but I like to think of it as tops are positive. So log of c to the 12th. And the denominator, and the base is d, d to the 8th is in the denominator, so I can expand that with subtraction. Now, what can I do to fully expand this logarithm? Exponents can be factored out to the front. So now I can expand this with 9 log of a plus 12 log of c minus 8 log of d. And that's how you expand a logarithm. Pretty simple, huh? All right. 2 more, and then we'll go to condensing logarithms. Okay, let's take a look at number 4 now. Log of c to the 9th, k to the 12th, over n, v to the 20th. Analyze the situation before we attack it. Okay, take a deep breath. The numerator can be separated with positives, and the denominator can be separated with negatives. So right off the bat, I can make this log of c to the 9th. Okay, k is on the top, so plus log of k to the 12th. N is on the bottom, so I'm going to make this minus log of n. There is no exponent, so I'm happy. And v to the 20th is also on the bottom, so I can make this minus log of v to the 20th. Okay. So far, so good. All right, now to fully expand it, all the exponents need to fly to the front as factors. So this becomes, all right, 9 log of c plus 12 log of k. Well, there's no exponent. I'm just going to leave this as minus log of n. And minus log of v to the 20th, well, that becomes minus 20 log of v. And that's fully expanded based on the power factor rule. There you go. All right, number 5. That was a lowercase b, but I didn't want anybody confused, so it's a capital B now. So it didn't look like a, it didn't look right, so I had to make it capital. So anyway, the natural log of w to the 16th b over m to the 24th, k to the 40th, g to the 20th. Take a deep breath. How do I expand this logarithm? Well, the tops can be expanded with positives. The bottoms can be expanded with negatives. So I'm going to make this the natural log of w to the 16th plus the natural log of b. Now we're on to the denominator, so everything in the denominator is going to get subtracted with negatives. Minus the natural log of m to the 24th minus the natural log of k to the 40th minus the natural log of g to the 20th. And now every exponent is going to fly to the front. So now, piece by piece, natural log of w to the 16th is going to bring that exponent out to the front. 16 natural log of w. There's no exponent for the natural log of b, so I'm going to leave this as plus the natural log of b. There's an exponent, minus ln of m to the 24th, so that's going to be minus 24 natural log of m minus natural log of k to the 40th, so that's going to be minus 40 natural log of k. And finally, minus ln of g to the 20th, that can be expanded with the power factor rule by doing minus 20 natural log of g. So that is how you fully expand a logarithm. If I can get some space, there we go. Okay, now moving on to condensing logarithms. So now, what happens if you have the now what happens if it's expanded and you want it together? The natural log of y plus the natural log of p. Well, if it's expanded as addition, how do I bring it back together? The product sum rule states that if it's addition expanded, it's multiplication condensed. So natural log of y plus natural log of p can be brought together with the natural log of y times p because of the product sum rule, just to warm up. And there's no exponents, so we're good. The end. The natural log, the log of q minus the log of k. What happens if it's subtraction expanded? How do I bring it back together? Well, if it's subtraction expanded, it can be brought together with division with the quotient difference rule. So now I can bring this together by going, hey, the first number minus the second number means I've got a numerator and a denominator. So this becomes the log of q over k. Let me make that a little bit cleaner. There we go. Because of the quotient difference rule. And there's no exponents, so I'm happy. Box. There you go. Number 8. 15 natural log of c plus 9 natural log of d. Now we're in business. Okay. Well, if there are factors out in front, and I've got an addition. Well, first thing what I'd like to do is bring these factors out in front inside of the logarithm. So if they're factored out of a logarithm, that means that they were originally supposed to be exponents. So this is natural log of c to the 15th plus natural log of d to the 9th. The reason why this works is because of the reverse of the power factor rule. Okay. Now if it's addition expanded, how do I bring it back together? With multiplication. Addition expanded means that it was originally a multiplication problem. The natural log of c to the 15th times d to the 9th. And that was from the product sum rule. All together. I like it. Number 9. 10 log of v minus 7 log of w. What can I do to bring this whole thing back together again? Well, I've got a factor out in front, and I've got a subtraction problem. Okay, so let me take this one step at a time. The 10 factored out means that it was originally inside of the logarithm as an exponent. So I'm going to make this log of v to the 10th. And that 7 factored out in front meant that it was originally in this logarithm as an exponent. So that's going to be minus log of w to the 7th. The reason why I can do that is because of the power factor rule. Okay, and now subtraction expanded. What does that mean? What does that mean if it was subtraction expanded? What does that mean condensed? Division condensed. Numerator minus denominator. So now I've got the log of v to the 10th, which is the numerator now, minus log of w to the 7th, which is now the denominator. So this becomes log of v to the 10th over w to the 7th because of the quotient difference rule. Okay, 3 more to go, and then I will Google share with you the test. 13 natural log of g plus 2 natural log of k minus 5 natural log of x. What do I need to do to condense this into one neat little logarithm? Well, all these factors out in front mean that they were originally going to be exponents. So let's make this the natural log of g to the 13th power. That 2 factored out means that it's part of the natural log of k to the 2nd power. All right, and then minus that 5 out in front means it's originally minus the natural log of x to the 5th power. Okay. So ideally, I would work from left to right and say that this is the result of the product sum rule. Addition expanded becomes multiplication condensed, and then, whatever that is, subtraction becomes quotient difference. I like my theory that positives are in the numerator and negatives are in the denominator. So I could just jump right into this and say, hey, this becomes the natural log. Positives go on the top. So we've got g to the 13th, k squared, and x to the 5th is a negative, so we're going to put that on the bottom. And that is how you completely condense this logarithm. There you go. I feel like Bob Ross. There we go. Happy little condensed logarithms. All right, 2 more and then we'll call it a day. Number 11. 8 log of q minus log of r minus 4 log of u. Okay. Piece by piece. 8 log of q means that this was originally an exponent at one point. So let's bring it all together. Log of q to the 8th. There's no factor out in front. I mean, I suppose you could put a 1, make that r to the 1st, but you know what? We could just leave this as minus log of r, okay? So far, so good. All right. And then that 4 factored out in front of the logarithm meant that this is part of the exponent for u. So this becomes minus log of u to the 4th. Okay. Now that I've got these all expanded and their factors into exponents, let's bring it all together. Positives go on the top, negatives go on the bottom. So I'm going to make this one neat little logarithm. Q to the 8th is on top. But we've got a negative log of r, so that r goes on the bottom. And we've got a negative u to the 4th, minus log of u to the 4th, so that u to the 4th can also go. So now this whole thing can become log of q to the 8th over r u to the 4th. And I know some of you guys are like, are you to the 4th power? Yes, I am to the 4th power. Sorry, I gotta amuse myself while I'm talking to myself. All right, last problem, number 12. 45 natural log of a plus 7 natural log of x minus 40 natural log of p minus natural log of c. Okay. Well, all the factors out in front can be combined inside of the logarithm as an exponent. So I'm going to make this the natural log of a to the 45th power plus the natural log of, that 7 can go into the exponent as x to the 7th power. That negative 40, well, minus that 40 can go inside as the natural log of inside of the natural log of p as an exponent. So minus the natural log of p to the 40th. And there's no exponent, there's no factor in front of the natural log of c, so I'm going to leave this as minus the natural log of c. Positives on the top, negatives on the bottom. Let's go. So now I've got the natural log of a fraction now, where a to the 5th is positive, a to the 45th is a positive, so it goes on the top. X to the 7th is a positive, so that goes on the top. P to the 40th is a negative, so that can go on the bottom. And C, there's no exponent, so I'm going to leave it like that. And that's how we completely condense a logarithm. The test will be shared with you on Google, on your email very, very soon. All right? Please complete this by Tuesday at 11:59 p.m. The next test will be on exponential and logarithmic functions, word problems. Yep, word problems with exponential functions. Have a good day.